Good morning and welcome to our session today. I'm Carol from Sunset Learning Institute from Marketing. I'm here with Chris Olsen, that will be our host today, our instructor. Chris, thank you so much for joining us. I'm going to talk a real brief about uh, Chris' career. So he has been a consultant, training author, and architect in a wide area of IT since 1993. So we do have an expert today. And he has been working with Cisco data center technologies since 2010, and also the release of Cisco UCS. So, Chris, thank you so much. I will launch a very quick poll if you guys can please answer for me, and then Chris will start our session. I will be here helping with the chat. So if you have any questions, anything, you can send, and we will try to answer for you during the webinar. Okay? Thank you.
Okay, everyone, welcome. Thanks for joining us. Thanks for your response there on the poll. Appreciate your time there. So confirming again, my name is Chris Olsen. I'll be the presenter here. Our topic is Nutanix Prism Administration on Cisco UCS. So we're looking at a combination of two technologies from two companies that have come together recently with a very big partnership. We'll see more of the details on that. So as far as our plan here, we'll take a brief look at the past, briefly on traditional SANs to see where certain technologies came from, and then we're moving to, which is hyper-converged infrastructure. So the details of what that is, what it looks like, and how it fits in with both Cisco as well as with Nutanix. What are the key pieces of Nutanix? So Nutanix and Cisco, to be clear, are different companies forged together in a very strong relationship in the data center. So what are the key pieces of Nutanix and how do they work together? And all that is centered around something very important called the Nutanix cluster, which is a group of servers that work together in a very logical way and are handled by software. There are several Cisco server options, and we'll take a look at those as well. And then all that leads to, well, what can we manage with? And that is Prism. Prism is a Nutanix management tool, and it comes in two flavors, both Element and Central. In Nutanix, we'll want both. Then we'll see the details of both Element and Central and how they work together. Okay, first, a brief look at the past here. So if you're really old like me, when I got started in information technology in the server world back in the early 1990s, servers or a host would have all of the elements traditionally built in. Or worded another way, what makes a server fast? I like to make a simple saying I call the 4 food groups. Don't take it too literally, it's not perfectly complete, but analogy from food to servers, the 4 food groups are CPU, RAM, disk, network. So traditionally, the host, the server, the network, all the blade, all the elements of the host were inside one individual host. Okay, then around 1990s, the idea of a storage area network came to play, which was sometimes known as a 3-tiered architecture, as shown here. The idea is, if we take those 4 food groups, CPU, RAM, disk, network, and take the disk portion out of the server, disk or storage or flash drive or solid state drive, anything that stores information if electricity is off, if that's removed, it can be put in a centralized storage location connected by switches. In Cisco, these switches are typically MDS, multi-layer director switches. MDS switch has been around for decades, and the idea is the host has the drive not in the host. So the MDS switch moves that storage information back and forth. Okay, so this is the past. This is the way things have been. To be clear, Nutanix does not do this at all. There is no storage area network in Nutanix. So where is the storage? And that's hyper-converged infrastructure. Storage goes back in the server itself. So if I take an individual server here. And once again, server, same as node, same as blade, same as host, same as rack-mounted server. Again, the hardware is different for each type of model, but they all share in common the 4 food groups: CPU, RAM, disk, network, now with something new. And that new piece with hyper-converged infrastructure is some type of software that takes our data and spreads it out. So this over here is a virtual machine, and that could be Windows or Linux, that has data. Maybe it's our database, email data, financial information, whatever it may be. Well, what if this server here were to go down? Then traditionally, any data running on top goes down. But with HCI, hyperconverged infrastructure, that's not the case, because this data has already been replicated over here, and perhaps over here as well, if we choose that, with something known as a replication factor. So the idea is, if this server fails, the data is not lost. Worded another way, what would be the best way to solve a problem? Here's a theoretical question. Best way to solve a problem. I would argue the best way is create the solution that's fully ready to solve the problem before we have the problem. So if we have the problem, the solution immediately solves it. We solve the problem before a problem, or we solve a failure before a failure. That's what hyper-converged infrastructure is. Cloud computing is based on this idea as well. So companies like Google, Facebook, Amazon, they're all doing hyper-converged infrastructure with different possible replication factors. So let's say we have some really important data here, and we have a catastrophic failure of the hardware. It's pretty rare. That it's not going to happen that often, but what if it does? Then the whole idea is the problem has already been solved. That data has already been copied over here and over here. So to do so, this needs two things: hardware and software to work together. They're a team. So is hyperconverged infrastructure hardware only or software only? No, it's definitely and always both. Software works with the hardware. And the boss is software. The intelligence is software. The software tells the hardware what to do, not the other way around. The software tells when we copy a file over, automatically replicate it to another server. So if one server fails for any reason, the data is intact and nothing is lost. This replication is quick and requires quite a bit of advanced technology to be able to do that. And we'll see that's built-in hyper-converged infrastructure. Okay, a little background also. Around 8 years ago, Cisco started into hyper-converged infrastructure. And with that, we now have lots of hypers, as I like to call it. Hyper, or above and beyond, or grouping things together, has a lot of different meanings. So let's be clear on each one. Hyper-converged, as shown here, are different servers with the storage distributed, controlled by software. Cisco's first product in this was HyperFlex. So if we go back around 8 years ago, HX or HyperFlex was a Cisco product, as you saw in the poll, which is specifically designed for hyperconverged infrastructure. Cisco actually acquired a company called SpringPath for several $100 million around 8 years ago. And the idea is that software was leveraged into VMware vCenter and Cisco servers with UCS. HyperFlex, I've worked with it from the beginning. Great product, reality. In September of last year, you may be aware of, but Cisco made an announcement to discontinue HyperFlex. The reason was to team up with the leader, which is Nutanix. So Cisco dropped its own product HyperFlex and teamed up with Nutanix. So Nutanix, by definition, is always hyperconverged. By definition, front and center, everything it does. You can't make it otherwise. It's always hyperconverged. And it has elements that have software that control whatever hardware we run on. So September of last year, Cisco and Nutanix got together and made a very strong partnership of hyperconverged infrastructure, which is Nutanix, running on Cisco UCS. And there's several options that are available, and we'll see those throughout. Next, hyperconverged is based on the idea of virtualization. So there is, our next hyper word, a hypervisor. There always is a hypervisor here. And a hypervisor, by definition, is an operating system that runs directly on the hardware, or bare metal as it's known. Any operating system that runs directly on a hardware is called bare metal. And that operating system by itself doesn't do much unless we do the intended purpose of running other operating systems on top of it, called guests or virtual machines. So the whole idea of hyperconverged infrastructure is we're going to have VMs or virtual machines running on top. And these are typically going to be Microsoft Windows or many flavors of or distributions of Linux. Many are supported, as we'll see. But the idea is this virtual machine is all software. It's a bunch of files, and it's using the hardware of the underlying hardware of the server, but distributed by the software. So the software does that distributing all automatically. So storage is controlled by software, by definition always. First piece of the puzzle is in Nutanix, we have a very common letter A, and this shows up quite a bit. If you ever studied ancient Greek or been to Athens, Greece, there's a beautiful natural rock called the Acropolis. And the Acropolis means the highest point, the pinnacle or the peak. Many thousands of years ago, the ancient Greeks built some amazing architecture on top of the Acropolis. Well, when Nutanix got started, that letter A was used here, as you'll see in many other places. So AOS here means Acropolis Operating System. It is a Nutanix operating system that's software that says we don't need a SAN or a network attached storage. So again, in SAN are ideas of fiber channel or fiber channel over Ethernet. Not needed, not used with Nutanix. AOS does their job, and arguably a lot better and a lot simpler, with less complex configurations for the infrastructure and still excellent fault tolerance in the event of a failure. So AOS is software, it is Nutanix, and it's always put in a Nutanix environment when we do the installation. It's part of the master brain. Now, AOS itself is not the hypervisor, but we'll see the hypervisor works directly with AOS, Acropolis Operating System. And that's specifically, where does the storage get used? Back in our 4 food groups, CPU, RAM, disk storage, or CPU, RAM, storage network. It's the storage, or disk, or hard drive, or solid state. That gets controlled by the software, which is Acropolis Operating System. AOS is the master brain to control where everything's going to take place here. And it does so all automatically. So you and I can see how well it's working. We can see the metrics, but once AOS is there, it does the job for us. We simply create our virtual machines, run them in the data center, and all that is taken care of by AOS. Next is a hypervisor. The word hypervisor actually dates back to the 1960s. IBM actually got it started back in the IBM mainframe world, where an operating system could run other operating systems on top of it. That's the idea of virtualization. Well, fast forward, Nutanix did a lot with virtualization in hyper-converged network, and the hypervisor is Acropolis Hypervisor. So this is an operating system uniquely with Nutanix that by definition runs other operating systems on top of it. AHV by itself, well, wouldn't do too much, but when we run other operating systems on top of it, it gets very powerful. So to be clear, as an analogy, VMware has a hypervisor, ESXi. Microsoft has one, Hyper-V. Nutanix has one, Acropolis Hypervisor. And as we'll see, all of these can be worked and managed together with Prism. So Nutanix is not unique only to Nutanix. It can run and operate and maintain and manage other hypervisors. So VMware ESXi, Microsoft Hyper-V, Acropolis Hypervisor, and we can mix and match these to your need. That also helps with migration and a high level of control of whatever hypervisor you want to run on. but the Nutanix unique one is Acropolis Hypervisor. AHV is also based a lot on open standards. There's another thing Nutanix has done quite extensively. Less proprietary protocols, more open standards, which usually results, as a trend in the information technology world, greater compatibility. The less something is uniquely and proprietary to any one vendor, the more it can be compatible with many other things. So Acropolis Hypervisor is based out of Linux kernel virtual machine, KVM, and the underlying Linux operating system is CentOS. You and I don't have to install CentOS here in HV. It's built in, it's there automatically. So how do we get these? We install our environment, and as we install AHV, that is the hypervisor that we're going to use on top of it. Once again, we could mix and match that with ESXi and Hyper-V. Also, to be clear, any one node or server typically runs only one bare metal operating system at any one time. On top of that, we can run many virtual machines. So on top of a node, you and I have a decision. We're going to run one Acropolis Hypervisor or ESXi or Hyper-V, but not both at the same time in the same node, just to be clear on that. Okay, the end result is, again, Microsoft Windows or many flavors of Linux run on top, and in those operating systems are all the data we can run in our data center, whatever it may be, from financial to manufacturing to Internet of Things to email to web servers, whatever it might be. All that data runs in the virtual machine that runs on the Acropolis Hypervisor. Next, again, the brain for this, sorry, let me step back. The management brain is Prism. So Prism is a Nutanix software management tool. Prism means done, operated, created by Nutanix. And as we'll see, there's two flavors. There's Prism Element and there's Prism Central. And typically, as you'll see, we'll use both. So how do we manage all this? Prism Element, Prism Central, together a powerful team. And with Prism, the whole idea is if we want to make virtual machines or virtual networking or set that up, Prism is the tool for that. Prism Central is in itself another virtual machine or a group of virtual machines in a fault-tolerant arrangement. Prism Element is built in the individual node running Nutanix software. Another big common trend in today's world is if I have a task to do and I got to repeat a task again and do it again and again, wouldn't it be nice to be able to automate it? So the idea of automation can be done with APIs. And Nutanix Prism supports probably the most common API called a REST API. Real simple, if you have software program 1, and let's say software program 2, whatever they may be, well, software programmers over the years have said, why can't we have software program 1 talk to 2? Maybe log in, ask it a question, get an answer, tell it to do something. How do software programs work with each other? The answer is an application programming interface. 24 years ago, a really smart guy named Roy Fielding decided, hey, this internet thing keeps taking off, and there's a lot of web browsers and a lot of web sites, so why don't make an API on the same idea? Example, what can you do if you take a web browser and you go to a website? Look at it, change it, log into it, log out of it, perform a change if we have secure access, of course. That's REST, representational state transfer. So REST is built into Prism. You don't have to enable it, and you don't have to use it. But if you have a task to do over and over again, you could write a Python script, for example. And that Python script can easily connect to REST and perform our tasks over and over again. Automation, orchestration is optimally done with an API like REST. There are other APIs that exist. REST, again, is so popular because we'll ask the question, how many web browsers are there in our world? How many websites are there? What can you do in a web browser to website? Add it all up, that's a pretty big list, and that's, well, what we can do with a REST API. So in this case here, again, all that is for all the tasks we would do inside Prism. Next is, very important in Nutanix, is the idea of a cluster. A cluster means a group of servers that work together, controlled by software. Software tells the hardware what to do, not the other way around. So in this simple example here I have a server, again, 4 food groups built in, CPU, RAM, storage, network. That server, again, could be rack mounted. It could be a blade in a chassis. It could be many different products. We're going to see our example on Cisco UCS. So in the Cisco world, Unified Computing System is the Cisco way of providing servers. UCS came out around 2009 timeframe. Unified Computing System means that the system of the networking and storage is built in and controlled and maintained by UCS. So the hardware is maintained by UCS, but the hyperconverged software is going to be Nutanix running on top of it. So what's a cluster? A group of servers that we logically group. Which do we group together? Any one you like. When we do the installation, as you'll see, you just select what servers you want to have together. Here I show an example of a cluster with 4 servers. Here's another one with 4. Can a cluster have 3 servers? The answer is yes. And 3 is typically the lower end. But Nutanix actually supports a cluster of only 1 server. Now, 1 server would not be a data center solution, but 1 server could be used for robo, remote office, branch office. So if we want to put some type of data closer to the users, far off, we could have a Nutanix individual server. A benefit of a single server, we save money on hardware. Liability, if this server were to go down, then there's no fault tolerance on it. So the world's smallest cluster is 1, but that has the least fault tolerance to it. And the cheapest cost because there's only 1 server to it. How big can a cluster be? Typically, a cluster is 8 to 16 in Nutanix. But depending on the software version, we can get up to 32. So 32 servers in a cluster that all work together. So I might say, well, where's my data? I have a virtual machine, and I can see the virtual machine is running on this server. Where's the data? Well, if I have a replication factor of 2 in the cluster, then Nutanix is automatically going to take that data and copy it to another host automatically. If I have replication factor of 3, they'll copy to a third. So everything we do gets fully, thoroughly, and quickly automatically copied to another node. You add a file, add a movie, add an image to a virtual machine. And quickly, Acropolis jumps in and says, I'm going to take that and I'm going to copy it and move it over. I'm solving the problem of failure before the failure occurs. The replication needs everything to work initially, but later, anytime, any day, hour, minute, second, if that server fails, the cluster solves it for us, unless, of course, we're on a single cluster. A little silly saying, I didn't make this one up, but it kind of applies. All hardware will eventually fail. All software will eventually work. All right, a little bit of humor there. Don't take it too literally, but the point is valid. When has the human race ever created a piece of computing technology that's perfect and has no chance of failure and will live forever? Doesn't exist, is the answer. So everything is going to fail sometime. The question is when. And when it does, what's the impact? And what's the best impact? Nothing. So and all that is done because of the cluster. The problem is solved before the problem happens. So when the problem occurs, solution's already there. Now, a virtual machine has 2 things. It's running in RAM with CPU, and it's on storage. So the cluster has already replicated the data. Well, but in RAM and CPU, a virtual machine is running on 1 node at any one time. What if that node goes down? No loss of data, but how do we get at a virtual machine if it's running with CPU and RAM on a disk that's down? So Nutanix supports high availability which will automatically reboot the virtual machine to another host in the cluster. It's all in the cluster. So virtual machines live in a cluster. Where? Potentially anywhere in a cluster. Why would we make a cluster bigger? Well, we can afford the hardware. We're adding more hardware to it, and we have more virtual machines, more data. We need more storage. We need more CPU power. Bigger clusters handle that. Connects. What if we start off with a small cluster, later want to make it bigger? No problem with that at all. We can easily add to it. Next scenario, what if we have a catastrophic failure of hardware and that blade is not working anymore? Okay, it's 10 years down the road, whatever it may be, and this blade has failed and the hardware needs to be replaced. What do? We simply evacuate it, meaning we tell all the virtual machines, use the other nodes. We remove the blade, add a new one in, and we make it part of the cluster. As soon as we do that, Nutanix says, welcome to the team. You're part of our cluster. I will use you to distribute the load. And all that is automatic. So disaster recovery, shouldn't it be stress-free, fun, convenient, not time-consuming? Well, that's what we get when we get a Nutanix cluster. So the idea is it's rare that a server will fail, but if it does, the impact can be minimized to as close as zero as possible, and it's easy to replace it. So future on, the users don't even have to know about it, other than the time of that virtual machine reboot in the event that the server failed while the VM is running. That's the real unplanned outage, but everything else is kept at a zero-time outage with the cluster. So again, biggest cluster, 32. 32 nodes. Typical is about 8 or 16. Connects. Prism element, as we'll see, where does it run? It's inside every node. How does it get there? Well, we install Nutanix. When Nutanix is installed, Prism element, the management tool, is put there automatically. Prism element is per cluster. Very important. So I have a different cluster, that's a different Prism element. Here would be a different Prism element. So now if we're going to manage, let's say I'm sitting over here from my workstation, and I want to manage this, I would have to take a web browser and connect over to Prism element over here in this cluster, and another tab over here, and another tab over here. If I have multiple clusters, each Prism element is only per cluster. So how do I manage all this as a collective whole? And that's Prism Central. Prism Central lets me do all the tasks of all the clusters, no matter how many there are. So will you always have Prism Central? No. If you just have one cluster in a small environment, that could be an example of only using Prism element. But as soon as you get 2 or more clusters, your management, ease of operation gets way better with Prism Central, because it allows us to get a single pane of glass to see everything running on both ends, or as many clusters as we may have. On a high end, we could have up to 25,000 virtual machines, all managed from one web browser to one central view of Prism Central. That's the high end, 25,000 VMs managed. The next is, every node has a mandatory brain called a controller virtual machine. This is critical. Hyperconverged software must have some software as the brain. And in Nutanix, that is a controller virtual machine. Side note, if you ever ran Cisco HyperFlex, as a couple of you noted in the chat, there was a controller virtual machine there as well. It's not the same or compatible with this controller virtual machine, but underlying, they're doing a similar job. So the controller virtual machine, first thing is it's a 1-to-1 on a node. How many are running? 1 for every node. What's a node? Again, a server, a host, a blade, a rack-mounted server. We're saying the same thing, and it's 1 controller virtual machine to each one. Nutanix must have this. Mission critical. This virtual machine is created when we install Nutanix. It's based out of CentOS Linux. So under the hood, there is a Linux operating system. But you and I don't have to manually create or configure this. You can do a little, but excuse me, for the most part, the default works fine. All we do is install Nutanix on the node, and it sure is going to get this controller virtual machine. And our job here is don't hurt it. Don't reboot it. Don't erase it. Don't delete it. Don't corrupt it. Just let it be. We can connect in. We're not blinded from it. We can look at it. We can get diagnostic information, but it's got to be there. Let it run 24/7, forever and ever and ever. Sabotage in Nutanix would be deleting controller virtual machines. That would be an extremely wrong thing to do. Don't ever do that for any reason, right? And we can also set up security to prevent that from accidentally occurring if someone clicks the wrong thing. But just make note, don't hurt it, let it run. It's the brain. It would be the same analogy of buying a pet and chopping its head off. It's not going to live too much more. Same with the node. So each node has that one-to-one controller virtual machine. And what is it doing? This controller virtual machine is taking our data, the virtual machine, and it's deciding where to put it. And our replication factor of 2, put it on another node. Replication factor of 3, put it on a third node. So this is the brain that's doing that. And next, in the world of Cisco, dating back to around 2008 or 9 timeframe, Cisco came out with the server product known as Unified Computing System, or UCS. And UCS has several ways to manage it. A more common traditional way is, as shown here, UCS Manager. So in this example, this screenshot is showing a single chassis. This example is one of the first chassis Cisco came out with, called the 5108. Inside of here, what is a chassis? Sheet metal that's rack mounted, that has 4 electric power supplies, and it has built inside of it fans, which you're not seeing here or there in the back, and node or host. So in this case, the 8 here refers to 8 individual nodes. Here's 1. Here's node number 1. Here's node number 2. Here's node number 3. So that node is going to run Acropolis operating system with the Acropolis hypervisor, and on top of that, minimally 1 controller virtual machine. Those 3 software elements are the brain. They work together, and it's all per node. And in each node will also be Prism element as well. Okay, now in a cluster, which of these can I put together in a cluster? Answer, any one you like. So for example, I could have Acropolis hypervisor here, here, and here, and then later add here. Well, we want to keep this running for some other function. Maybe it has VMware ESXi running for some other function. No problem with that at all. So side note, Cisco HyperFlex, when it was installed, it demanded everything to do it only one way. Nutanix says you choose the node, or don't choose the node to be in a cluster or not be in a cluster. Nutanix retains high flexibility in that. Okay, could we choose one individual node here? This is slot number 4 or blade number 4. Sure, I could do that. Next, does Prism get rid of UCS management tools, assuming we do Nutanix on UCS? The answer is no. Does UCS Manager replace Nutanix? Again, the answer is no. They're a team. They work together. UCS Manager runs on top of 2 physical devices called fabric interconnects. Those fabric interconnects are used to manage the blades down below. Next very important thing about UCS is this item over here, which is by definition a service profile. A service profile, by definition, are software settings of a blade. If you ever reboot a software settings of the hardware settings of the blade in software, and the service profile can be added in a blade or removed. Analogy, if I back up a server, do I back up the hardware settings? No. But now we do with the service profile. So any setting of the hardware can be backed up and restored. Service profiles mean hardware failure and restoration is real easy. Literally, I demonstrated this many times over the years, but it's 5 clicks of the mouse. Full catastrophic failure of the blade, 5 clicks of the mouse. We can take our service profile and point to another blade, bring it up, it's repaired. So whatever setting was on one blade, we can move it to another. A service profile is always 1-to-1. Now, a service profile is the hardware settings. So how does that relate to AOS and AHV? Well, the operating system that runs on hardware gets the settings of the hardware. What are those settings? In UCS, that's our service profile. So a service profile does not replace Acropolis Hypervisor or AOS. It tells it what to do with the hardware. All hardware settings are in a service profile. The bare metal operating system running on top, Acropolis Hypervisor with AOS, those together get the settings of the service profile. Once again, UCS Manager and Prism, they're a team. They don't compete, they work together. Okay, next question. Is it required to run UCS Manager with Nutanix, assuming I want Cisco blades? The answer is no. This is a common solution. It's widely done. It's not the only option. Another option is I could have rack-mounted C-series servers. Not shown here, but a C-series server from Cisco is a dedicated rack-mounted server that does not by itself contain central management. Could I run Nutanix on that? Absolutely, yes, for sure, as long as it's dedicated and supported hardware. So there's a definite important hardware compatibility matrix that has to be complied with for sure. In better words, is every server Cisco ever made supported with Nutanix? That's a no. Are there quite a few to choose from there in the hardware compatibility list? That's a yes. Okay, next. Next option is around 5 or 6 years ago, Cisco came out with the next evolution of higher performance servers and used the fun letter X. So UCS-X, as shown here, are Cisco's newest higher performing servers. Okay, and if you attended Cisco Live or did so remotely this year in June of this year, there was a major announcement of Cisco and Nutanix with support of UCS-X. So Nutanix software is now supported with UCS-X. Okay, what are the key benefits of UCS-X? The 4 food groups got a lot bigger. That's really the essence of it. CPU, a lot more. RAM, a lot more. Storage, a lot more. Networking, a lot more and a lot faster. All of this is one blade or one node. So if I were running Nutanix here, this would have Acropolis Hypervisor, AOS, running one controller virtual machine all on top of it with Prism element all built in, and that could be part of a cluster, which might include this other blade or this other blade and so on. Another thing UCS has introduced, UCS-X, has introduced is the idea of the graphics processing unit. That little startup company, NVIDIA, you may have heard of now in a $3 trillion valuation. Well, GPUs, graphic process units, can be made by NVIDIA or Intel, and either of them can go right inside UCS-X for high graphics processing or machine learning, or artificial intelligence, or cryptocurrency. Anything with high computational needs, we can add another brain. Part of the 4 food group can be added with added GPUs. So UCS did not have GPU support. UCS-X can have it. Doesn't have to, but it can, depending on what you're doing with this. Another example is VDI, Virtual Desktop Infrastructure. So Nutanix and UCS-X, a very powerful, strong VDI solution. VDI is where the user's desktop is not on their desktop. It's just a simple keyboard, video, mouse with a simple operating system that connects remotely. All the data would be stored right over here. So what if a user loses their laptop or gets a their physical device stolen. There's no data on it. VDI keeps it all centralized. Hospitals, government agencies do a lot with that. So Nutanix, UCSX, another powerful example of them teamed together, all of which can be managed by Prism. Next, how do we install Nutanix? What's the name of the installation tool? It's called Foundation. It's not called Nutanix installation, it's called Foundation. So Foundation is a file of different types you download from Nutanix. Foundation is step one. Foundation is how do we get Nutanix and install it on Cisco UCS? So the example here is there's a version of Nutanix Foundation that runs on Microsoft Windows. It's an MSI type file. Download it from Nutanix, take a Windows operating system, double click, install it, install Foundation, and then run through the template. In this case, what we're seeing here is an actual screenshot of doing an installation of Nutanix. And what we're doing is selecting the nodes. In this case, notice this is going to be a 3-node cluster. And what we have to do is assign this information here. This information has to be manually entered. This information is automatically discovered of the chassis by Foundation. And this serial number is built into UCS Manager itself. So if I step back here, in this example, if I chose this node, this node, this node, any you like, then these together, in the simple example, would be part of our cluster. How do I know which I'm selecting? If I look right below here, you'll see a serial number, and Nutanix Foundation found it. It discovered it. So this was not manually entered, but Foundation went out to the node, found it, and said, there it is. What do you want to do with it? And we selected and says, you're going to be part of the Nutanix cluster. As we're doing this, what goes on each one of these nodes? Acropolis operating system, Acropolis hypervisor, the controller virtual machine, Prism element, all done with that checkbox right there. If we don't check a box, then Nutanix won't help nor hurt it. It'll just work independently. Connects over here, regular, is all about, again, our 4 food groups. Regular means, well, you're going to have this node of CPU, RAM, storage, network, all working together. That's regular, all 4 food groups. Next scenario, what if we have a case where we have some applications that are very computationally intensive, but not storage intensive? So they need a lot of CPU, constant calculations for them. So what we can actually do is make a separate node, and I would choose the other option here instead of regular, just for CPU. So there's no storage running on it at all. It's like borrow the brain in the cluster with the CPU. So the computational processing is borrowed from that other node if you want the node to only have CPU. Benefit of a CPU-only node, you don't have to pay for storage inside it. Cheaper on hardware. Liability, well, there would be no storage. Benefit, that CPU can be spread across the load of the virtual machines. Okay, or another example, what if we wanted storage only? So now let's say we have another collection of applications that are very data intensive, but don't compute quite as much, like imaging, storing large images or files that are huge in size. And of these huge in size, we got a lot of them, terabytes to the petabytes. And we want to save them in an individual node, but that node doesn't have to do much processing. It just has to save them. So I could change that regular to that node. Assumption, if I do that for storage, assumption, you have a lot of storage in that node that has to be pre-installed. The hardware has to be there for that to make any sense. Okay, but again, that checkbox during the install of the node will then create the cluster and install the Acropolis hypervisor on top of it. And we could have added security elements during the foundation that's set up. So for added cryptography of connecting in and added security access. Okay, all of which is installing. So foundation is installation of Nutanix. Again, it does not replace UCS Manager. It works with it. They're a tight team. Foundation can also create service profiles. There's another option underneath the cluster here where you can create the service profile. So Nutanix will install the service profile for you in UCS Manager. And the assumption is we've selected in Foundation, we're going to install based out of UCS Manager in this example. Okay, but after the installation is done, day-to-day management, that's all Prism Element, Prism Central. So how did Prism Element get installed? Answer, check the box right here. And then Prism Element gets put on our device. Prism Element is a web server. And you can access it from the command line. We can program with REST. But typically, how do we manage it? Well, take a web browser, surf to the website, which is the host, which is running, Prism Element. So Prism Element, again, manages only that cluster. So the scope of management is only in the cluster that it's in. Worded another way, how many clusters is Prism Element in at any one time? One and only one, right? There's no way to make Prism Element manage another cluster. That has no meaning. But in that other cluster, if we have one, it will have its own Prism Element. Next is, if you have two or more clusters, that's a good example of why to run Prism Central. So what is Prism Central? It's the manager of managers in Nutanix. It doesn't replace Prism Element. It doesn't replace UCS Manager. They all work together as a team. So the master brain is Prism Central. Prism Central is a virtual machine, or ideally 3 virtual machines. So we could have 3 of these that work together. And the 3 virtual machines that work together give us a fault-tolerant method of managing. Where does the Nutanix Prism Central virtual machine run? On our AHV, Acropolis Hypervisor. Which one? Anyone you like. Which cluster does it run? Anyone you like. So how do we manage Prism Central? We take a computer, Windows, Linux, Apple, whatever it may be that we're managing from, that you and I are sitting at, open up a web browser, and go to the website known as Prism Central. So the client is, well, the web browser. The web browser is all we need for that. So what do you have to install on the client? Well, get a web browser. And the common ones work well. Updated versions of Chrome, Firefox, Microsoft Edge. Don't use Internet Explorer. That's a bit outdated. But to manage Edge, Firefox, Chrome are ideal. Here's an example of Prism Element and what it looks like inside of it. Prism Element, by definition, once again, is I'm looking in a cluster. Okay, a little example here. When have we ever heard a user say, hey, my computer is too fast. I'm on my computer, I'm going to the website, and as soon as I type in the name, it's there right away. It's just too fast. Silly trivia question. When have you ever heard a user say, our computing system is too fast? Said nobody ever. I've been in the IT world now over 30 years, and that's me being silly because no one ever said computers are too fast. So if someone, on the other hand, says the network is down, the network is slow, the server is slow, the internet is down, or whatever expression a user might say, what is it really causing? Something is slowing it down. Is it the data center? Well, we can see. So we can look inside the latency and see the actual amount of time that gets calculated. So throughout this cluster, we can see the total latency measured in milliseconds as the total amount of time for data to be accessed with Acropolis Hypervisor, with AOS, all managed by the controller virtual machine. How much time did that take? It'll never be 0 time. Nothing works in 0 time. But the goal is to get it as fast as possible. And here we're on the order of a few thousandth of a second. What happens if a computer, like a virtual machine, is running on something and the CPU is maxed out? All right, performance, it's going to be terrible. no matter what technology we use, if you have something running on a thing with the CPU maxed out, that thing's not going to run well, whatever the thing is. A router, a switch, a firewall, a laptop, a computer, a tablet, a Nutanix server. So it's good to know, where are we at here? So inside here in the dashboard, I can see example where we're at with the overall view here. So here's looking at Prism Element in the dashboard, and I get the vital statistics of our performance. How well are we doing things? How many hosts do we have? What do we have to look at? Something's critical here that's showing us visually. You may want to check that out. Somebody shut it down. Is the controller virtual machine still there? Is there any loss of network connectivity? Here's our little note just so we can dig into that and look inside of it. Another open standard Nutanix supports is Intelligent Platform Management Interface, or IPMI. IPMI is an open standard created by server and network vendors about 15 years ago or so to allow management of a hardware of a server in an open standard. And the result is IPMI. Nutanix fully supports IPMI and actually requires it. During the installation with Foundation, you have to enter in the IPMI addresses that'll be used to manage the server. Simple analogy. If you take a Microsoft remote desktop session and connect to a remote server, and you reboot the server, what happened to your connection? You lose it, of course. If you telnet or PuTTY or SSH into a network device and you reboot it, your connection is clearly gone. But not with IPMI. IPMI lets us connect to a device and reboot it and not get disconnected. Intelligent Platform Management Interface is an open standard. Once again, Nutanix supports that for remote management. And here I can see if I have any poorly chosen security passwords entered in. The next, how much network is taking place. We can see that here by the overall bandwidth. So again, part of our 4 food groups on networking with the Ethernet connections going out, are they saturated? If Ethernet is fully saturated and the network is a bottleneck, all servers are going to look pretty slow. So we want full eyes on that to ensure that the bottleneck is not in our environment. We can see that fully here from Prism Element. Okay, next, traditionally, I mentioned the word disk or storage or hard disk drive, but more modern examples are flash, solid state drive, or really fast non-volatile memory express, NVMe. These are examples of pay a little more money, get a really fast storage device. How do we know? Well, we can measure that by the input output per second, right? So how fast can information come in and out of storage is typically measured in IOPS, input output per second. And we can see that here in our graph. Again, if this graph starts going up, that'd be a bad thing, in that we might be getting closer to capacity. What if we hit capacity? Well, then Nutanix, add another node. That would be a good example to add another computational node or another regular node to help the cause. And we don't have to guess at that. We can see that right inside here with Prism Element. Here's an example of looking at the dashboard of Prism Central. So in this example, we take a web browser, we surf to the virtual machine, which is a website, which is Prism Central. And on top of that, I can see all the different clusters. And from here, I can drill down into those individual clusters and get more information on that. So Prism Central, once again, is the manager of managers. Does Prism Central get rid of Prism Element? No. We have them both. They work as a team. So ideally, a good way to manage things is take a web browser and open up 3 browser tabs. One to Prism Central, another to Prism Element, another to UCS Manager, and now you got the full view of everything from one browser. Inside Prism, Nutanix, well, got in the networking business. In other words, Ethernet switches can be physical or virtual, as shown here. So here we're seeing a look at Prism Element looking at an Ethernet switch. That's all software. How do you plug in a cable to a software switch? Well, there's no physical connection, but there is virtual networking built inside. And that virtual networking can be created or added to or isolated. So in networking, if all devices connect to everything, networking looks easy. Caution, less secure. So typically, we don't want every computer to talk to every computer. That would be lesser secure. I mean, how does a hacker or a cyber criminal break into something? Because they can connect. What if they're isolated? So that isolation can be done with networking here to add security. So we can control which VMs are going to talk or not talk to others by networking of a that's all built inside. Again, this is a Ethernet switch that's all software that's built inside. And it's based out of OVS, the Open Virtual Machine Switch, another open standard. So an open standard in the Linux world was adopted by Nutanix, and that's built right inside of here. And finally, one of the key things we're going to do is, with Prism Central, manage virtual machines, create a virtual machine, install it, reboot it, delete it, move it, create a new one, or we could even make snapshots. So the idea of a snapshot is I record a moment in time of its configuration. So I can take everything on a virtual machine, make a snapshot of it. Then let's say some changes take place, but I want to go back to where I was before. I could simply revert the snapshot. Virtual machines can be cloned. So if one virtual machine is made and we want to make many of them just like it, we can clone it. And cloning makes an exact copy. So we can also jump in and say, well, if I make an exact copy, let's not make it too exact. Because some things like, well, a duplicate IP address or a duplicate MAC address, we don't want things perfectly duplicated. Or a Microsoft Active Directory domain SID. Those numbers in Microsoft Active Directory, you don't want to duplicate them. So perfect cloning shouldn't be that perfect. So what we can do is interject the cloning with our management of virtual machines and change the things we want, but keep everything else relatively the same. Microsoft names of computers. Duplicate names, not the best thing. We want unique names. So when we clone, we can keep that all unique itself. Okay, with that, and with the convergence of Cisco and Nutanix last year, we've seen quite a big demand of, well, how do I do this? And how do I get hands-on on this? And how do I dig deeper under the hood of HyperFlex migration in Nutanix on hyperconverge? So we have a course recently created for that. And you can see here some of the guaranteed dates. You can jot those down and notice on sunsetlearning.com as well. These are going to run for sure. I'll be teaching them and hope to see you on them as well. In addition, we have a couple other Nutanix webinars coming out. You can look for these on the webinars link on Sunset Learning. They'll be announcing the dates in the upcoming weeks and months as well. Okay, on that note, thank you very much for attending on our hour presentation here. And some questions here in chat. Amin asks, will be the same HX servers 2000. Amin, thank you for noting and commenting. So the HyperFlex blades on the 2000s, some of those do have compatibility for Nutanix, some do not. So it does require, Amit, it's not a black and white answer of all yes, all no. So there is a hardware compatibility list that specifically describes the Nutanix supported Cisco servers. So Amit, your answer is some yes, some no. Amit also asks, so Nutanix will work now with UCS-B only or C Series 2? That question was before, and the answer is all the above. So it's Nutanix works with UCS-B and, UCS-B, UCS-C, and UCS-X, provided that the specific hardware model is on the hardware compatibility list. That's the critical requirement. And that list is growing more and more in time. It's getting bigger because the relationship of Cisco and Nutanix keeps growing, but it's not 100%. So you do have to check that hardware compatibility list on that.
Thank you so much, Chris, for today's session. I appreciate. I shared the link for our course here at the chat. We will provide the recording later, and I hope to see you all again in the next webinars. Thank you so much, and also in our guaranteed to run dates. Thank you so much, Chris.
Great, thank you. And thanks all for attending, and everybody have a great afternoon.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.